Hi guys, so we just completed module 8.1 in which we were talking about multiplication properties of exponents, and now we are on to module 8.2, and this one is about division properties of exponents. So let's look at our learning target. I can find quotients of monomials. And we talked about what a monomial was in yesterday's lesson, that it has only one term. And then the next thing I can do is I can find powers of quotients. So let's talk about the vocabulary. We have two vocabulary words. One is quotient of powers, and the other one is power of a quotient. So we are going to start with quotient of powers. And then basically to divide two powers with the same base, and we know that in this case the base is 2. You just subtract the exponents. And for any non-zero number a and any integers m and p. So if I say a and we have the integers m and p. Okay, so if I have this, all I'm going to do is I'm going to take a and I'm going to do m minus p. You're just subtracting the exponents. Now, let me tell you why we are doing that. So, let's say if I have this one, I have 2 to the 8th power. Okay, I have 2 to the 8th power that is given to me. So we know this means that my base number is 2, right? And so that is my factor that I am going to use to multiply by itself 8 times. So that means 2 times 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 2. 1, 2, 3, 4, 5, 6, 7, 8. And then I have 2 cubed, which means 2 times 2 times 2. Okay? So 2 times 2 times 2. Now you know that you can simplify anything from the numerator to the denominator. So instead of me doing something like 1, 2, 3, 1, 2, 3 and simplifying, which that color was really not the best. Here. Okay? And then I'm left with 1, 2, 3, 4, 5, which is what? 2 times 2 times 2 times 2 times 2. And so I'm left with just 2 to the 5th power. So instead of making it so elaborate, in my quotient of powers, all I do is this. I take the powers, my base is 2, okay? And I take the powers and I just take the exponents and I just subtract the exponent, okay? So 8 minus 3. And I get 2 to the 5th power. As simple as that. Instead of sitting and doing this whole elaborate process over there, all I do is, if I'm doing quotient of powers, I am going to take those exponents and subtract. Remember when we did multiplication, we added it. In the opposite of multiplication, which is division, we are going to go ahead and subtract the exponents. And that is the only difference between multiplication and division of powers. Okay, or quotient of powers. Okay, so let's do some problems now. So here are 2 problems that I have put on the board and we are going to work out each of them. So if I look at the first one, it's saying b to the 5th power c to the 7th power divided by b squared c. So the first thing that I want to do, I'm going to use the quotient of powers property. And so what I want to first do is that group the powers with the same basis. So I am going to go ahead and group this. I have b to the 5th power over b squared. So I'm just going to group the same basis. And b are the same base. And then c and c are the same base. And then I am going to use the quotient of powers property, and I am going to go ahead and look at my B, and that is B 5 minus 2, right? Because I'm just subtracting the exponents. So I have B 5 minus 2, and I have C to the 7th power minus 1. If there's nothing written, that means it's to the first power. And now once I have that written out, I'm going to go ahead and solve it. And I get B 5 minus 2 is going to give me 3B cubed, and C 7 minus 1 gives me 6. So B cubed and C to the 6th power, so B cubed times C to the 6th power. This is my simplified version of this problem. Let's do the next one. Okay, so if I'm looking at this, do I have another A to group this with? I do not have an A to group so it's just going to be A squared. Okay, and then I'm going to group my B to the 9th power, and B to the 8th power. I'm going to group my C over C, which basically means C to the first power. So this is nothing but C to the first power if it's just written as C. Okay, and then I'm going to group my D to the 4th power over D. Okay, and then when I start simplifying it, there is nothing to group because this means over 1, right? So I'm going to get A squared, and what is 9 minus 8? So I'm just going to write B, which is B to the 9th power minus to the 8th power, right? And then that is times C 1 minus 1, and I have times D to the 4th power minus 1. Okay, so then when I solve this, I am left with, I have A squared. I'm going to just write the answer up. Well, let me go ahead and write the answer over here. Okay, so I'm left with A squared, and I have B, and I have 9 minus 8 over here as my exponent. So I'm left with just 1. So that is B. With C, I'm left with nothing because both of these have simplified. This and this have simplified. And I'm left with D. The power is 4 minus 1. So I'm left with D cubed. So my final answer is A squared times B times D cubed. And that's how I just solve using my quotient of powers. Okay? So here's a word problem where we are applying division of monomials, and it's talking about chemistry. At sea level, there are about 10 to the 25th power molecules in a cubic liter of air. In the stratosphere, about 30 kilometers above the Earth's surface, the same cubic liter of air has about 10 to the power 23 molecules. Approximately, how many times as many molecules are there in a cubic liter of air at sea level as they are in the stratosphere? Now, please remember when it says how many times, basically what does that mean? That you are, when it's saying how many times greater, how many times larger, how many times, so it's not multiplication, it is the inverse, which is division. Okay, so we are basically again using our quotient of powers property. Okay, our A to the power of P, which is what? We are doing A and the power of M minus, so we are subtracting these exponents, right? So when I look at this one, I have 10 to the power 25 over 10 to the power 23, which is 10 to the power 25 minus 23. So these are my exponents, and I'm left with 10 squared, which is what? 10 times 10. And that gives me my answer as 100. So there are about 100 times as many molecules in a cubic liter of air at sea level as they are in the stratosphere. And that's basically what this means, okay? So let's look at another word problem with shopping. Canada's West Edmonton Mall claims to have the largest parking lot in the world, with about 3 to the 9th power parking spaces. And California's Glendale Galleria has about 3 to the 8th power parking spaces. So the West Edmonton Mall has how many times as many parking spaces as the Glendale Galleria? So it's saying how many times, that means we are dividing, okay? So we have 3 to the 9th power over this one, okay? To about this much, which is 3 to the 8th power. And so I am going to use my quotient of powers property, and I subtract the exponents, and I get 3 to the 1st power, which is nothing but 3. So the West Edmonton Mall has 3 times as many parking spaces as the Glendale Galleria. So the next property that we are going to talk about is the power of a quotient. So to find the power of a quotient, find the power of the numerator and the power of the denominator. So let's look at the first one that I have put over there. And I have put a over b to the power of m. So for any real numbers a and b, where b is obviously not equal to 0, and any integer m, if I do this, I am going to find a to the m power over b to the m power. And that's basically what this is when I have them within the parentheses. So then I have got to apply that power to both the numerator and the denominator. Okay, so let's look at the example that I have sitting over here, which is 2/5, and then we have to the 3rd power. So this basically means that I'm going to have 3 of this factor and 3 of this factor, okay? And so we have 2 times 2 times 2. So look, we have 3 factors here because it's cubed. And what do we have at the bottom? We have 5 times 5 times 5. So once again, it's cubed. So I have 3 factors here also. Okay, and so this gives me 2 cubed over 5 cubed as my answer, which is simplified. And then of course I can do 2 times 2 times 2. 2 times 2 is 4 times 2 is 8, and then over 5 cubed, and then I can simplify that way. Okay, but that's what the power of a quotient property means. So let's go ahead and solve some problems on this. So here are 2 problems that I have put on the board. Let's start with this one first. Okay, so we are going to go ahead and do power of a quotient, so which is 5a squared. So I'm going to take this as 5a squared cubed over 6 cubed over 6 cubed, because I told you that you've got to do that same thing to the numerator and to the denominator, because it's the entire thing is within the parentheses. So you've got to do the same. The factor is happening 3 times here, and this factor is also happening 3 times. Okay, so now next you're going to use a power of a product, because this is now going to be 5 cubed, right? That is 5 cubed, because 5 times 5 times 5, take the coefficient also. And then since I have the a squared and the 3, what am I going to do? I'm going to do the a squared times 3. So a squared times 3. Because I'm using the power of a product and then power of a power property. Okay? Over 6 cubed. And then that gives me 5 times 5 is 25 times 5 gives me 125. This is 125. And what is 2 times 3? That gives me 8 to the 6th power over 6 times 6 is 36, and then 36 times 6, because we have 6 times 6 times 6, and that gives me 216. So this is my simplified version of this problem. Okay, so 125 a to the 6th power over 216. All right, let's do the next one. And we are again going to use all our properties. So we have, I'm just going to look at this straight up. And I know that this is going to be 5j cubed L squared to the 4th power over 7k to the 5th power to the 4th power. Okay, and then I can go ahead and I can separate, and this is going to be 5 to the 4th power, right? And then it's going to be my j cubed times 4, okay? And then it is going to be L squared times 4, because that's the power of a power property. And then I'm going to have 7 to the 4th power times k to the 5th power times 4. Okay? And then when I simplify, this means 5 times 5 times 5 times 5. This one. This is what it means. 5 times 5 times 5 times 5. I always suggest that group them, and we know that 5 times 5 is 25, and so is another 5 times 5. And then if I look at this, is 25 times 25, which is 625. Okay, so this gives me 625. Okay, and j 3 times 4 is 12, and L 2 times 4 is 8. Okay, over. Then I have 7 times 7 is going to be 49. And then since it's 7 to the 4th power, that means 7 times 7 times 7 times 7. So 7 times 7 is 49. So 49 times 49 based on the trick that I just taught you over here. All right. And you're going to get 2,401. 2,401. And K. And then we have 5 times 4, which is 20. So here is my solution. Okay, so just look at those steps really quick. All right, going to do another problem. So here's another problem that I have put up for you on the board. And let's look at this one. So we can see that this is x to the 4th power y divided by xyz, and the whole thing is squared. Okay, so in this, I am going to go ahead and I am going to first use power of a quotient. And so I have x to the 4th power y squared over, we have xyz. This whole thing also is going to be squared. Right? And then the next thing I'm going to do is I am going to say x to the 4th powers, because we know power of a power, right? So we are going to take x to the 4th power times 2 and y to the 1st power times 2, that just gives me here. This is what this means. Okay? And then I'm going to do, here this is first power, first power, first power. So we are going to just do the multiplication, which is x squared times y squared times z squared. And then I'm left with, what is 4 times 2? I get x to the 8th power y squared over x squared y squared z squared. And then I am going to use the quotient of powers, and here I'm going to carry this over here. And so I can see 8 here, I can see 2 here. So it's x 8 to the 8th power minus to the 2nd power, right? And then I've got y squared and y squared, and we know that means we can easily cancel this out, okay? Because y squared and y squared are going to be simplified, okay? Because it's y2 minus 2. And then I have just this left over my z squared, which is a different base, so there's nothing to simplify. And so I'm left with x to the 6th power over z squared. And here is my solution. And that basically concludes our lesson on the division properties of exponents, how to find the quotients of monomials, how to find powers of quotients, of basically using the properties that we have talked about, which is the quotient of powers and powers of quotient, to simplify these problems. And that concludes our module 8.2, division properties of exponents. You all have a great day, everyone.